Hi, everybody. Welcome to the CIQ webinar. So today we're going to be talking about using Fuzzball and using it in particular for AI and to be very specific, using it for sovereign AI. So a lot of teams right now are using AI for development work and debugging, writing documentation, all kinds of things. Um, and they don't want to be outsourcing all of that AI to a third party anymore. And they want to be doing something called sovereign AI, where you actually are hosting your own inference models locally, and your data never leaves your own machines and it stays exactly where you put it. So that's going to be the subject of what we're talking about today, and some of the ways in which Fuzzball enables you to be able to have sovereign AI running in your infrastructure. So we got two different guests here that we're going to be talking with today. One is Hideto Hara, who is kind of a new intern working at our newest intern working here at CIQ. So how you doing, Hideto?
I'm pretty good. How are you?
Pretty good. And then later on, we're going to be bringing Wolfgang Resch in, and he's going to be talking a little bit about the same topic as well. We've got two really great demos that we're going to be sharing with you today. The first is something that Hideto has been working on since he started with us. He's going to be running, so it's a really cool demo. It's going to be running on an Nvidia DGX, and it's really cool because it's talking about how CIQ is using Fuzzball ourselves internally to actually solve a real problem that we've got and produce some stuff that is important for us. I'll talk more about that in a minute. That's a really exciting demo. And then the second demo that Wolfgang is going to do is going to talk about how to run an inference model and then automatically scale it up and scale it down using Dynamo, so that if you are hosting this for a large group of people to all be hitting the model at the same time, you're not going to run out of resources. It's going to go ahead and scale up for you, and you're going to be able to host that for a large group of people. So feel free at any point in time to drop questions in chat, and we're here to answer, even though this is actually pre-recorded, but we're actually sticking around and we're here to answer your questions if you want to drop them in chat. Okay, so let me go ahead and talk a little bit about the first demo that we're going to do. So we had kind of a problem. We ran into a little bit of a problem here at CIQ where we wanted to produce a lot of videos about Fuzzball. So we want those to be, so it's kind of funny because I'm going to be talking about training. And when we talk about AI and training, usually that means a very specific thing. We mean something totally different here. So we want to create videos that are training videos. In other words, they're going to train people. And we also wanted to create some promotional content for Fuzzball so that people know more about Fuzzball. And recording these videos is very labor intensive. Usually if I'm going to do it, I set up a green screen and I, put a bunch of stuff together. I use a different camera. We record a bunch of takes, we cut them together. It takes several days to record a single video. And we want to put out a lot more videos a lot more quickly than that. Also, things are changing with Fuzzball quickly enough that we can't, take so long to record videos. So the idea came about, why don't we use AI to create these videos for us? And around the time that we had that idea, Hideto came on and joined the team, and he's got access to a DGX. And so it was a natural fit. And so he went ahead and installed, Fuzzball on the DGX. And he very quickly was able to create a template in our workflow catalog that allows you to quickly and easily give it a prompt and generate a video. And so that's kind of the demo that we're going to be doing today, is talking about that. So Hideto, do you want to maybe take it away a little? Do you want to say anything before we actually jump into the demo, or talk about that at all?
Sure. Yeah. What this workflow does, it basically just you give it a prompt, a plain English prompt. It plans the tutorial, writing in like using an AI model, using a Quencoder on my GPU on my Spark, and it creates a plan, it creates a script, and it drives a Fuzzball web interface, and it records that, and it voices over it, and it kind of walks you through a tutorial on Fuzzball. and how to use it. Uh, yeah, that's about it.
Cool. Let's dive in and actually look at it if you don't mind.
Absolutely. Yeah,
So
so this
so
is what you first get when you open up Fuzzball. It's a catalog. It's a catalog
well
file, so you
well
can.
let's just back up just a minute. Sorry to jump in.
No
Um,
worries.
so if for some people might be new to Fuzzball altogether, right? So it'd be good to talk a little bit about what Fuzzball is in this context. So Hideo has installed it on his DGX, but you can install Fuzzball on AWS. You can install it locally on any, on a cluster. You can install it anywhere you like. And Fuzzball, it at its heart, it's a container orchestration platform, and it's a container orchestration platform really for high performance computing and for AI workloads. Um, Here we're looking at the web UI. It's important to note that everything that we're looking at here in the web UI is all API driven. And I think that we were talking about this a little bit before the session, and Hideo said he actually prefers the CLI. So anything that you can do in the web UI here, you can actually do in the CLI as well. So I think you were saying that you actually drive this primarily using the CLI, but today we're going to be showing the web UI just to kind of make sure that people are up to speed and kind of it's helpful for demos to kind of show the web UI. Sorry to jump in and take over there.
No worries. Yeah, so this is the web UI. It's just the easy to use, just simple version of Fuzzball. It comes with a free catalog of all of the fuzz files that run different scripts for different tools that we have.
Yeah. Yeah, absolutely. I want to unpack that a little bit more too. So that we have this workflow catalog that has all these templates within it. And these templates are all pre-created for you by CIQ engineers, and they come with Fuzzball. So the page that Hideo was showing you previously has all these pre-configured workflows that'll run out of the box for you. However, you're also able to make your own entries within the workflow catalog. And that's what Hideo is showing you now, is that he's actually created his own template locally on the DGX, and he can just reuse that over and over again.
And yeah, there is also a copy button, so you can copy and edit your own version of my template and honestly put whatever brand you want on it and have it run any tutorial for any company's UI that you would want to use.
So what does it look? So what does it look like to actually run this workflow, Hideo?
Right now, it's just setting your plain English prompt, and then setting how many cores you want your AI to use, how many cores you want to use for your render, and the speed of how fast you want the narrator to talk. And you can turn I got a little mascot in there. He talks you through the tutorial.
Fuzzy.
And we have a little thing to turn the intro on and off. So
that's awesome.
These are just a few little parameters that you can set for Fuzzball to work around. You can set more or less depending on how much interaction you want. And after that, you just click run. We already have one running right now. You can see it. It'll take you to this screen here. It'll show progress, and you can click through and see your logs and events and see what's happening in your Fuzzball. See what you're working with.
Now,
yeah, so this is just the timeline of events that's happening. So first, it creates or calls on the model to create the little script. It creates all the volumes that stores the renders, the voice, and that's it. And then it pulls some images, and then it sends the little crawler after your website, and it kind of clicks through and records that, and then edits it together in the render service, and then it'll port it forward to a local host web page where you can actually play through it and see what's going on.
Now let's find.
So this is a training video. I mean, once again, we're using training in a very different sense than we would normally use it within the AI sphere. But this is a training video. It's worth pointing out that Hideo just created just now. And this video is now we could put this up on the website, and I mean, we check the accuracy of it, and as long as it's good to go, then we can use this to show people how to use Fuzzball. So it's a really, 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 really great thing that you can just put these together that quick. It's cool that you can do all this within the workflow catalog, and that makes it really easy for anybody to just be able to jump in and run these. Well, do you want to show really quickly? It looks like the server started up. Do you want to show how you can actually connect to the server and interact with it in real time as well?
Yep. And usually you would have to like port it forward through the command line, but it's nice enough to where it just puts a little button there, and it goes and kind of just opens it right up for you. And then here you go. You can see it.
That's really cool.
Yeah.
So it's really cool that you can do this, within the, we're kind of getting up to time here. So I'm going to be kind of wrapping it up fairly quickly, but I was going to say, it's really cool that you can do this within the workflow catalog. Can you also show how you can actually open, so the workflow catalog, I should go back and say, it has templates that enable you to be able to have all those little buttons and prompts and everything that Hideto showed, so that a new user can go in and just interact with the workflow and run it. But you can also open this up in the workflow editor. So if you go back to the actual running workflow, and then actually go to that's actually the template. So Hideto, if you go back to the workflows and then click on the running workflow, and then go open in the editor in the upper right-hand corner. So now we can actually get in and mess with the actual YAML file that was rendered by that template. And so you can get really low level and, create anything that you want here and, change it around. It's really powerful that you're able to do that. And it's great that you got the flexibility to be able to give this to a, kind of a new user, or you can actually give this to an expert and they can do whatever they want with it as well. So, just to kind of like, recap, CIQ had a real problem that we really want to use sovereign AI with our own DGX and be able to create these videos really rapidly and be able to iterate on them quickly. And it was so easy to do that we had Hideto come in, and in a matter of weeks, you went from not having seen Fuzzball at all to being able to install it, bring it up, create your own workflow, run it, and actually, start solving a real problem that CIQ has and dog fooding our product at the same time, right? So maybe now we could transition away from looking at the demo and just sort of talk a little bit more about what your experience was like using this. And just kind of like, discuss that a little bit more. So how was it to be able to use Fuzzball to be able to create this and to start solving this problem?
So yeah, as you said, I am an intern, and I have really no previous experience with any software engineering or anything like that. So easy use was actually surprisingly easy. You can vibe code most of this stuff, and with it's pretty straightforward. Like, you can kind of see everything that's going on. It gives you really good error logs. So when you do break something, you can fix it very quickly with the help of, honestly, a local model that works. The Quan model is very good for vibe coding this stuff. And yeah, it's it's just it took me maybe a few days to get used to it. But after that, I was able to run every workflow through the CLI and see every log. And I was able to get work done fast and quite a bit easier.
Sorry, we were talking a little bit previously about this workflow and how Playwright is one of the places that's a little bit more kind of fiddly and brittle, because Playwright is the piece of this workflow that's actually pointing to different things and clicking on buttons and interacting with the website as it creates the video. Mm-hmm. And we were talking about how that needs some adjustment but how Fuzzball actually enabled you to be able to do that quickly and easily, because you don't have to worry anymore about tearing the workflow back down, allocating resources, spinning it back up, doing, having it reproducible. All that stuff is taken care of is taken care of for you, and you can just iterate, right? And just iterate very, very quickly and be able to get everything lined up. You want to talk a little bit more about that?
Yeah, iteration is pretty easy. So through the course of this, probably within a few days, I went through around 40 versions of this, just breaking it and fixing it and breaking it and fixing it. And I could go back because I have all of my templates saved and I can see what broke and what got fixed and what works and what doesn't. And yeah, Playwright was kind of hard to work with, but getting up and running with it, like getting a base model that showed the screen, clicked through tabs, took probably 2 hours. The rest of the time I spent trying to map out the website.
That's awesome.
Button placement and all that.
Cool. Well, thank you so much. Thank you so much, Hideto, number one, for joining CIQ and for doing all this great work. I mean, it's really appreciated because like the work that you're doing is actually replacing a lot, not all, but a lot of the stuff that I do, and a lot of the other folks do as far as creating videos and everything. And also thank you for kind of on short notice, jumping in and being a guest on this webinar. I really appreciate that. It's fun talking to you, man.
Absolutely. Thank you.
Yeah, cool. All right, excellent. So now I think that we want to transition a little bit and we want to start talking to Wolfgang. So the problem that Wolfgang is trying to solve, or did solve pretty quickly within Fuzzball, is the problem of, okay, so you've got an inference model that you've trained up and it's ready to go, and you want to serve it out to a large group of people. Fuzzball allows you to do that really easily because these services that run within Fuzzball, you're able to change the scope and make those either accessible, just by yourself or to everybody in your group or to the whole world if you want to as well. But what do you do when those services start getting hit by lots and lots of people and it starts to overwhelm the resources that you've allocated? Well, that's where Dynamo comes in and auto scaling comes in. So you're able to scale up and scale down these inference models in order to handle, whatever the demand is that you've currently got coming in. And so he's going to show you an example of that. And once again, we're talking about sovereign AI. We're talking about hosting all this stuff on your own infrastructure, on your own machines. And that way, all this data, if you're serving a model for your entire company, for instance, maybe you're serving a coding model that allows all of your engineers to be able to, use AI to be able to debug code and create new code and stuff. What you're working on never goes out to a third party, right? It all stays local. It all stays on your machine. You don't have to worry about anybody else having your IP. So I'll hand it over to Wolfgang and he'll go ahead and do that demo and talk about that for you.
Hello, my name is Wolfgang Resch, and I'm going to show you how you can create services in Fuzzball that scale automatically in response to load. I'm going to do this with two different workflows that I'm going to share with you. The first one will explain the basic mechanisms of how auto-scaling works in Fuzzball. And in the second one, we will actually create a auto-scaling LLM-based inference engine and connect it to a local open code running in a Docker container. Okay, the first workflow, we will start here from the Fuzzball workflow catalog. This workflow has two services. A worker service that scales itself depending on how much CPU utilization it records. The second one presents a front end that load balances between the different replicas of the worker job. There's only a few things we can change here. Let's say, for example, that we want between 1 and 3 replicas of the worker service. And I'm going to start running this. And while we're waiting for this to start, I'm going to open this in the editor to give you a basic idea of how the machinery is wired up. First, the worker node. The worker service is basically runs a Python script. In this example, this Python script, every time in response to a request to one of its endpoints, will start a process that simulates a calculation and occupies one CPU core for 1 minute. This is a persistent service, and it's defined generally like all Fuzzball services are. It runs code, it exposes an endpoint, one for checking whether it's healthy, one for actually submitting work. And the thing that makes this particular job auto-scaling and more interesting than a general service is this tab over here. Here we can, again, determine how many minimum replicas should exist of the worker service, how many maximum. For a service that scales itself, you need at least one to start with. And then we can define triggers for scaling up and scaling down. Let's look at the scale up trigger here. We're not running a particular server emitting metrics here, but Fuzzball itself collects several basic metrics, like, for example, total CPU usage in CPU nanoseconds as a monotonically increasing count. So we can, for example, say if the rate of increase, meaning actual utilization, on average over a minute exceeds 1.5 in any container, start a new replica. And there's a cooldown period that we define, meaning that if this trigger fires, another trigger can't fire for at least 30 seconds. That prevents, for example, if you have multiple replicas at scale, reaching that threshold, they won't all fire scale up events at the same time. Similarly, there's a scale down. If load falls below 0.2 cores on a particular replica, it will get scaled down. And there's a cooldown period of 60 seconds. So that's the worker part that makes this work. The front end presents an endpoint for the user to connect to, and it round robins requests coming from the user to the different worker replicas. And the way it does that is by using a dynamic config. It gets injected at some regular interval, an environment variable that lists all available worker services. So at the beginning, this will just be one worker node. And if there's a scale-up event, it will show two. And it writes that to a temporary file, and the code in the front end reads that every time a request comes in and picks one worker at random and submits work to it. So that's the general idea. There's an auto-scaling block that determines scale up and scale down triggers. That lives in the worker here. And then there's the front end has a dynamic configuration that tells it how many workers are available. That's what it looks like in the user interface. And if we look at the actual textual representation of this particular workflow, we can see, let me see if I can make this bigger. So in the worker, this is the part that determines auto scaling. So it's a straightforward translation of what we saw in the user interface. We have a minimum of one replica, a maximum of 3, and then there's just the formulas that determine scale up and scale down. I didn't mention this earlier, but these formulas are PromQL queries. And again, even without the job emitting any metrics, even though the jobs can emit metrics, Fuzzball itself creates several synthetic metrics, including CPU and memory usage. So that's the worker side of this. And then on the front end side of this, we have the dynamic configuration. Again, this is what gets populated with the list of available worker nodes at a regular interval. Okay, and this is what presents the front end to the user, and it submits work to the worker service. So going back here, where our workflow started, and in this case, we have the front end that's already running, and we have two replicas that have not started and one replica that has started, consistent with us requiring a minimum of 1 and a maximum of 3 replicas. This particular front end exposes a web interface we can connect to. I'm going to put that in a split view here. And basically all this service does is I can push this button and it will send a request to a randomly selected replica that is available. And that will then do a calculation for a minute. And we can see there's one idle replica and 2 replicas that haven't started yet. So now if I submit, let's say, 5 requests, because there's only one replica running, they will all get routed to their one replica. But if we look at the events for this workflow, and let me make that a little bigger, we should see within about a minute that a scale up has started. And the reason why this takes a minute is because we created a trigger that requires a load of greater than 1.5 over on average for a minute. So it will take about a minute for the first replica scale up event to happen, and then it'll take a second for that actually being instantiated. So we'll wait just 1 second here. Oh, and here we are. So you can see that submitting several requests here triggered a scale up of the workflow service, and we have a second replica that started up. And now if we send requests, we can actually see that they get routed to different replicas. So you can see that counter increasing in both of them. And that should actually eventually trigger another scale-up event, which will instantiate replica number 3. So we'll wait just a second for that. And here we are. We just got a scale-up event. And now we have all 3 replicas running. And if we send requests now, they will get load balanced between all 3. And we'll let this finish, and then we'll see it automatically scale down once these computations, these synthetic computations have finished. Okay, we're back after a little bit, and we can see that the first scale down event has happened, and replica 1 was scaled down, and we're down to just 2 running replicas now. And in just another minute or so, we will see the second one scaling down. So we'll be back right then. And here we are. We had that second scale down happening, and now we're down to just 1 running replica plus the front end that actually distributes the work between the replicas. And you can see the same thing in the user interface that's presented by this replica. So that's the general idea of workflow services. And let me just recap and show you an illustration of how this, of the bits and pieces that go into making these work. Okay, to recap what makes an autoscaling service work in Fuzzball. First of all, you need a service that defines an autoscaler block. In this case, this service scales itself because it always has 1 replica running, so it can detect when that replica gets busy and start a new one. The autoscaler block defines upper and lower bounds for the number of replicas and rules for instantiating new replicas and rules for scaling down the number of replicas. In this case, and then we also need this front-end service. This front-end service does a couple of things. It presents that user interface that I showed you to the user, and it submits work to the worker instances. The way it knows how many instances there are and how to reach them is through a bit of dynamic configuration. So this service has a dynamic configuration block in its workflow definition. And this is how Fuzzball injects how many replicas there are and how to reach them. Okay, on to workflow number 2. As I mentioned, this will be an autoscaling workflow that runs a VLLM-based inference engine as the scalable part of the workflow. And then it has a front-end service, which allows the user to connect to the load-balanced replicas and connect it to a local open code instance. So there's a couple of things that are added to this workflow that we didn't have in the previous one. So let me just go briefly over those. First of all, here is the actual worker process in the Fuzzball YAML file. What you can see here is that the autoscaler uses a different kind of metric. The autoscaler, to decide whether or not a new replica should be started, looks at a metric exposed by the LLM. And in this case, the metrics we're using is the number of pending requests. So if there's one or more pending requests over a certain period, then it will trigger a scale-up event. And if nodes sit idle, it will trigger a scale-down event. And this is made possible because of this new block that we didn't have in a previous example. where we're basically telling Fuzzball that there is a Prometheus compatible scrapable endpoint presented by this workload. And this is the /metrics endpoint presented by the LLM serve. So in the previous one, we just used a synthetic metric that Fuzzball collects for all services, which was CPU utilization. In this case, we're using a specific VLLM-based metric presented as a Prometheus scrapable endpoint. And that's used to scale up and scale down the number of replicas. Next thing that's different, this workflow has an annotation called fuzzball.io/connect/ the name of the service. In this case, this gives special instructions for how to connect to the front-end service. And the front-end service, like in the previous job, is the service that load balances between our different backends. And here what happens if we connect to this workflow from the command line, it will execute the script, which will generate code. It will use that to inject information about how to connect to our workflow, in particular credentials needed, what the name and the name of the endpoint is, and so on. And it will then execute that locally. And this, in our particular case, we're using this to basically obtain the credentials and configure a local open code instance running in Docker to connect to the load balance service, to the auto-scaling and load balance service in Fuzzball. Okay, let's go and get this started. Let's submit this workflow. We will switch over to our web interface. Here it is. And here we see it starting up. So while we wait for it to download the model, start the front end and the replica, we will be right back. And all our services have started up. Let's have a quick look at this just to make sure that it all looks healthy. And yes, we can see that the worker running the inference model with VLLM has started up and is ready to accept connections. So go back to the command line and let's connect our open code session to this. And it needs one command line argument, which is a local directory for the session. And here we are running open code connected to the remote server. No, we don't want this. In the meantime, let's open up a second terminal here and do the same thing. Wrong place. It's the same thing except a different project directory. Okay, two connections here. This. Just doing some example queries. And let's have a look here. If we, no, we have not cost enough load to scale the scale and increase yet. Let's see. I don't think I should have set up an automatic load. I don't think this will actually trigger a scale-up event. But at any rate, you saw how we were easily able to define a inference service that would scale with load and connect open code instances running locally on your computer to that auto-scaling inference service.
Okay, so just to recap, we showed you, we talked today about AI and, using Fuzzball, and with a particular focus on using Fuzzball to do sovereign AI workloads. And we showed you 2 demos that were really pretty cool. The first of which was Fuzzball running on a DGX, and actually, we're dog fooding Fuzzball, using it right here within CIQ to solve a real problem that we've got, and that is to produce, more training videos, to produce more promotional videos, and produce more content. And we had a really fun conversation with Hideta Hara talking about how he joined the team and was kind of tossed in the deep end and was able to swim very quickly because Fuzzball is so easy to use. So, appreciate him coming on and talking about that. And then we talked to Wolfgang Resch, and he showed how you can take these inference models and you can use Fuzzball to stand them up really quickly and to be able to scale them up and scale them down as you need to in order to allow a large number of people to use these models. All right, cool. So this is just like, Fuzzball is a really multi-purpose tool, right? It is the Swiss Army knife of HPC and AI. And there are all kinds of things that you can do with it. So this is just kind of like a little fraction, a little bit of what you can do with Fuzzball. And we're going to be, showing more demos in the future and doing more webinars and talking more about the different things that Fuzzball can do. If you have topics that you're interested in, if you want to know more about Fuzzball, you can go ahead and email us at info@ciq.com. Or if you have questions that you didn't think of, during the recording here that you want to talk to us about later, then that would be a fine thing to do. You can email us there as well. All right. So thank you for attending. Hope you had a fun time. I'm sure I did. And we'll talk to you later.